Neptune, the icy giant that lies at the far edge of our solar system, has always been a source of wonder for both scientists and people who dream about the mysteries of space. But things are changing now. With the help of new technology and groundbreaking scientific discoveries, we are finally able to see Neptune more clearly than ever before. Thanks to recent missions sent by space agencies, we have received some amazing close-up images of Neptune's atmosphere. And now, Neil deGrasse Tyson has just revealed something about Neptune that has shocked the entire science world. What did he reveal? And what does this mean for us? Join us as we discuss this and more. The Voyager 2 mission. In August of 1977, a small spacecraft named Voyager 2 set off on an incredible journey through our solar system. This wasn't just any trip, it was something that no spacecraft had ever done before. Voyager 2 was built to explore the far reaches of our cosmic neighborhood, places that were so distant and mysterious that we had only guessed what might be there. It was like sending a scout out into the wild unknown. The launch of Voyager 2 marked a huge moment in space exploration, like the start of a grand adventure we were all excited to follow. After traveling through space for 12 years, Voyager 2 finally reached Neptune in 1989. By that point, the spacecraft had already passed by other planets like Jupiter and Saturn, gathering incredible data. But Neptune was different. It was a far-off icy giant. As Voyager 2 got closer, it started sending back amazing pictures that showed us this distant world in ways we had never seen before. The spacecraft revealed swirling clouds of bright blue and mysterious bands of atmosphere that left scientists in awe. So, what does Neptune look like? Neptune's breathtaking beauty was on full display. Now, imagine what it was like to see Neptune up close. The planet looked like a giant version of Jupiter but dressed in beautiful shades of blue. But this wasn't just a calm and peaceful place. Voyager 2 detected something astonishing, a massive storm tearing across Neptune's atmosphere. This storm was so big and intense that it looked like a swirling dark gray hurricane. The spacecraft also spotted 4 strange rings surrounding the planet, almost like delicate, faint halos. And to top it all off, Voyager 2 discovered 6 new moons circling Neptune, adding even more to the mystery of this distant planet. This was a huge moment for science. Voyager 2 had uncovered things we didn't even know existed, and it did all of this while zipping past Neptune in a matter of hours. Even though this encounter was short, the images Voyager 2 captured would stick in people's minds forever. They showed a planet full of wonder, storms, and surprises, an icy giant that was beautiful but fierce at the same time. After traveling more than 7 billion kilometers, you would think that Voyager 2 would get to spend a lot of time exploring Neptune. But in reality, the encounter lasted only a few hours. Even though the spacecraft had journeyed so far and waited for so long, it only had a brief moment to capture what it could. However, this fleeting visit was enough to provide humanity with something we had never had before, close-up views of Neptune, a world that had once seemed so out of reach. People often remember one particular image from that encounter, a shot of Neptune with towering white clouds and storms raging across its surface. This picture became famous, and for a long time, everyone thought Neptune was a deep, rich blue because of that image. But the truth is, Neptune's real color is actually more of a soft, greenish blue, a detail that often gets overlooked in the excitement of space exploration, capturing the elusive Neptune. If you ever try searching online for more pictures of Neptune, you might be surprised to find that there aren't many. It seems odd, especially considering that Voyager 2 got so close, within 4,950 kilometers of Neptune's surface. So why don't we have more pictures of this planet? One big reason is that Neptune is so far from the Sun. In fact, it's 30 times farther from the Sun than Earth is. That's an enormous distance, and because of that, Neptune gets only a tiny bit of sunlight compared to what we have here. When Voyager 2 finally caught up with Neptune after being boosted by the gravity of other planets, it was traveling at an unbelievable speed, about 27 kilometers per second. This meant it didn't have much time to hang around and take photos. Add to that the dim light, and you can see why capturing images of Neptune was such a challenge. But even with these challenges, Voyager 2 still gave us an unforgettable glimpse of a planet that had been nothing but a distant dot in the sky for centuries. It was a fleeting moment, but one filled with discovery and wonder, reminding us of the incredible power and beauty of our solar system. Neptune's perplexing blue hue. Neptune might seem like a tiny dot far away in space, but its bright blue color and strange atmosphere make it pretty fascinating. Still, getting good pictures of it was not easy for Voyager 2. Since Neptune gets only a tiny amount of sunlight, just 0.1% of what we get on Earth, the spacecraft had a hard time taking clear pictures in the dim light. Voyager 2 had to get creative. By carefully using its thrusters to adjust its position and taking longer exposure shots, it managed to send back some of the closest and most amazing pictures of Neptune ever seen. Just a few hours before Voyager 2 flew past Neptune, it took a very detailed picture. In that image, scientists saw some fascinating features in Neptune's upper atmosphere, thin, wispy clouds that looked a lot like the cirrus clouds we have here on Earth. But unlike Earth's clouds, which are made of water vapor, Neptune's clouds are made of frozen methane, giving them an otherworldly look. Imagine these clouds stretching for thousands of kilometers, running parallel to Neptune's equator. Each cloud streak is about 50 to 200 kilometers wide. They float so high that they cast shadows on the hazy layer about 50 kilometers below them. What's really cool is that, even though Voyager 2 had already flown by all the other gas giants, Neptune was the first planet where scientists got to see these cloud shadows. More recent observations from the Hubble Space Telescope have shown that these clouds can appear and disappear very quickly, showing how active Neptune's weather is. When Voyager 2 took its famous pictures, powerful winds were whipping around the planet, some reaching speeds of 2,100 kilometers per hour. That's 3 times faster than the winds on Jupiter and nearly 9 times faster than any winds we experience here on Earth. The Great Dark Spot. Voyager 2 also revealed that Neptune has some of the wildest weather in our solar system. During its flyby, the spacecraft spotted a huge storm called the Great Dark Spot. This storm, shaped like an oval and about the size of the Earth, was similar to Jupiter's Great Red Spot. But even though it looked calm in pictures, the Great Dark Spot was an intense cyclone that showed just how extreme the weather can get on Neptune. What's really cool about this image is that the center of the storm on Neptune looks pretty clear. There are hardly any clouds, making it look like a big dark hole cutting through Neptune's atmosphere. Neptune is one of the amazing ice giants in our solar system, and it's about 4 times wider than Earth. Its radius is around 15,300 miles, which is pretty huge. Neptune has a massive volume of about 15 trillion cubic miles. To give you some perspective, that's 58 times more than Earth's volume. This mysterious planet is mostly made of water, methane, and ammonia. Unlike Earth, Neptune doesn't have a solid surface to stand on. Instead, its thick atmosphere goes really deep into the planet, all the way down to a layer of methane and ammonia ice that surrounds a rocky core. Here's something even more interesting. Scientists think there could be a superhot ocean deep inside Neptune. Even though Neptune looks icy on the outside and has a cold-sounding name, the conditions inside are the opposite of cold. But how can this be, especially when Neptune is so far from the Sun? Sunlight takes a long time to get to Neptune, about 4 hours. Neptune is also super cold on the outside, with temperatures averaging around minus 360 degrees Fahrenheit, making it one of the coldest places in the solar system. Most of Neptune's atmosphere cooled off between 2003 and 2018. But from 2018 to 2020, scientists saw some warming around the South Pole, probably because the atmosphere's chemistry changes with the seasons. The mystery of how an ocean could form inside Neptune hasn't been solved yet, but scientists have some ideas. One theory is that the planet's internal heat might be caused by gravitational forces or from interactions with its largest moon, Triton. However, not everyone agrees on this. For example, scientists Sloan Viktorovich and Andrew Ingall think it's pretty unlikely that oceans could form on Neptune due to its internal heat. They estimate that there's only about a 15% chance of it happening now. Based on their calculations, they think it could take 1 billion years for that chance to rise to 40%, if Neptune keeps cooling down over time. Another interesting theory about Neptune's intense internal energy is that the planet might have collided with something huge a long time ago. Neptune is unique because it gives off almost 3 times as much energy as it gets from the Sun. This odd energy output might have something to do with Neptune's large tilt, about 28 degrees, which is similar to Earth's tilt. #### Neptune's seasons and atmosphere. Neptune tilts on its axis just like Earth, so it has seasons too. But here's the twist. Each season on Neptune lasts around 40 years. If you want to imagine a year on Neptune, it's about 165 Earth years long. But while Neptune's year is super long, its day is really short, just 16 hours. Because of this fast spin, Neptune has incredibly strong winds. Neptune's atmosphere is made mostly of hydrogen, around 80% of it. Helium makes up about 19%, and the last tiny bit, about 1%, is other gases like methane. The reason Neptune looks so blue is because of the methane clouds in its atmosphere. These clouds absorb red light from the sun and reflect blue light, giving the planet its stunning color. ### Methane on Neptune and Uranus. Methane plays a big part in how both Neptune and Uranus look. Even though they are really far from the sun, they still get some sunlight, but it's a lot weaker than what we get on Earth. Scientists have been fascinated by Neptune's deep blue color for a long time, and they're still trying to figure out exactly why it's so striking. One interesting thing is that Neptune has clouds made of methane ice crystals that are high up in the atmosphere. These clouds scatter sunlight, making Neptune appear even bluer. It's a bit like how the sky on Earth looks blue because of the way light gets scattered in our atmosphere. Neptune's atmosphere is always changing with huge storms and super powerful winds. Uranus, on the other hand, looks more of a pale blue. What's really wild about Uranus is that it's tilted so much that it almost lies on its side. This extreme tilt causes intense seasons. For example, during its long polar winters, Uranus can spend years in complete darkness. This lack of sunlight makes it harder for high methane clouds to form, which is why Uranus looks different from Neptune. Both planets have other gases too, like hydrogen, helium, and a little bit of ammonia. The way these gases mix with the temperatures and winds in their atmospheres creates a lot of interesting stuff for scientists to study. ###the mysteries of Neptune. Neptune is a planet full of mysteries, hidden beneath its icy atmosphere. Its bright blue color comes from the methane in the air, which gives it a striking look. But it's not just the color that makes Neptune special. It's a planet of extremes. The storms on Neptune aren't your average storms. They are massive, some stretching across thousands of kilometers. These giant tempests create dark and white patches on the planet's surface, caused by Neptune's fast spin. It completes a full day in just under 16 hours, which makes the winds incredibly strong. In fact, Neptune has the strongest winds in our solar system. One of the most famous storms on Neptune was called the Big Dark Spot. The Voyager 2 spacecraft discovered it, and it was a huge deal. This storm looked like a giant cyclone, spinning faster than any storm we have on Earth. But then something surprising happened. When scientists looked at Neptune again with the Hubble Space Telescope, the storm was gone. This disappearance showed just how quickly things can change on Neptune. Neptune also has a magnetosphere, which is a space around the planet that is controlled by its magnetic field. What's interesting is that Neptune's magnetosphere is tilted in a strange way compared to the planet's spin. This odd tilt creates complex interactions with the solar wind, which causes beautiful auroras or light shows in Neptune's atmosphere. ###storms on Neptune. In 2018, the Hubble Space Telescope spotted a new storm forming on Neptune. This reminded scientists of another big storm that happened in 1989, nearly 30 years earlier. These storms are different from the ones we see on Earth. They don't just appear and disappear quickly, they take years to form. This suggests that something complex is happening deep in Neptune's atmosphere, causing these huge storms to build up slowly. But the story gets even more interesting. When the 2018 storm first started, it was moving south, and scientists thought it would eventually fade away. But then, out of nowhere, it changed direction and started moving north. This surprised scientists because it didn't follow the usual patterns they expected from storms on planets. As if that wasn't enough, a smaller storm broke off from the big one. NASA scientists think this little storm might play a role in breaking up the big storm, which is something they've never seen before on Neptune. To make things even more intriguing, there are bright clouds made of methane within these storms. Scientists call them scooter clouds because they move so fast. No one is quite sure what drives these clouds, but they suggest that there are some pretty complicated forces at work deep in Neptune's atmosphere. ###Neptune's rings. Neptune has something pretty cool in common with other gas giants. It has rings. These rings were captured in amazing detail by the James Webb Space Telescope in 2022. This was the first time we had seen them so clearly in over 30 years since Voyager 2 last took photos. The image didn't just show Neptune's rings though. It also showed some of its moons, all surrounded by the icy beauty of space. Neptune has 5 main rings and they all have names. Each one is named after an astronomer who helped us understand the planet better. The closest ring is called Gal. It's very faint and made mostly of dust, stretching 26,000 miles with a width of about 1,240 miles. It's like a delicate band around the planet. Then there's the Leverrier ring. It's brighter but a little uneven in its size, measuring about 62 miles across. After that, we have the Lassell ring. This one is the largest, measuring 2,485 miles wide. Even though it's huge, it doesn't have much dust, only about 20 to 40%, so it looks almost clean and clear. Arago is the 4th ring. It's harder to see because it's smaller and sits far out at a distance of 35,540 miles from Neptune. Finally, there's Adams, the narrowest ring. It's located about 39,724 miles from Neptune and is only about 22 miles wide. What makes Neptune's rings even more fascinating are the arcs. These are bright bands of dust that appear along the edge of the rings, creating a stunning sight. The arcs each have names. freedom, brotherhood, courage, and equality. These names make them even more interesting. Unlike regular rings, the arcs aren't still, they move. In fact, brotherhood and equality are constantly trading material and changing their size, which makes them a puzzle for scientists. Nobody is entirely sure how these arcs formed. But one researcher, Matt DePater, thinks they might have formed when something collapsed inside Neptune's Roche limit. That's the area where a smaller object can break apart because the planet's gravity is stronger than the object's own gravity. #### Neptune's moons. Adding to the intrigue of Neptune's ring system, the James Webb Space Telescope recently took amazing pictures of Neptune's rings and moons. Neptune has 14 moons, and the telescope managed to capture images of 7 of them. The moons are split into 2 groups, regular and irregular. The Webb telescope focused on 6 of the regular moons, which are closer to Neptune. Some of these moons, like Despina and Galatea, help shape Neptune's rings. They act as shepherds, guiding and keeping the dust in place. This makes the rings look sharp and defined. Despina and Galatea have special orbits that influence how the rings are structured. Their gravity helps keep the ring particles from spreading out too much. The Webb telescope also took pictures of Triton, Neptune's biggest moon. Triton is interesting because it moves in the opposite direction of Neptune's rotation. Scientists think Triton might be a captured object from the Kuiper Belt, which makes it a special target for study. Triton has geysers that shoot out nitrogen gas, creating a thin atmosphere and suggesting it's still geologically active. One of the coolest things about the Webb's images is how bright Triton looks. It shines like a star because it reflects a lot of sunlight, thanks to its icy surface. Triton is covered in nitrogen ice, which bounces back about 70% of the sunlight it gets. Triton is the largest of Neptune's moons, even bigger than Pluto. It has a diameter of around 1,680 miles, and it makes up almost all the mass of Neptune's moons combined. Triton is also one of the coldest places in the solar system, with surface temperatures dropping to a frigid -391 degrees Fahrenheit. Its icy surface reflects sunlight, adding to its extreme cold. Triton always shows the same side to Neptune, a phenomenon called tidal locking. Despite its size and cold, Triton is fascinating because it's geologically active and very cold. Triton is a unique moon in our solar system, with a backward orbit compared to most moons. It's thought that Triton might have come from the Kuiper Belt, far from Neptune, and this makes it even more interesting to scientists. A cosmic journey. Neptune is quite the cosmic magnet. At some point it pulled Triton into its orbit. Imagine Triton as a cosmic traveler who suddenly found itself in Neptune's gravitational grasp. To avoid crashing into Neptune, Triton slowed down and settled into a unique orbit where its poles and equator take turns facing the sun. It's like Triton is playing a game of hide-and-seek with sunlight. However, this rebellious move has its downsides. Triton's unusual path might create trouble for Neptune's other moons, potentially leading to collisions. Unlike Jupiter, which has a busy crowd of moons, Neptune only has a few companions. Triton's arrival shook things up and highlighted how different Neptune is from its gas giant cousin Jupiter. Triton stands out among Neptune's moons. It's not just any moon, it's a captured wanderer from the Kuiper Belt, a distant region filled with icy objects. Picture Triton as a cosmic nomad that got pulled into Neptune's orbit. When Voyager 2 passed by in 1989, it took pictures of Triton's surface, showing a landscape full of frozen plains, towering cliffs, and mysterious dark streaks. What fascinated scientists were the huge plumes shooting out from Triton's surface. These plumes suggested that something was going on beneath the ice. By looking at the craters on Triton, scientists found clues about its violent history. Some craters looked brand new, hinting at recent impacts, while others showed signs of erosion, suggesting that Triton's surface has been shaped by icy geysers and cryovolcanism. But the most exciting discovery was yet to come. Scientists think there might be a hidden ocean beneath Triton's icy shell. This ocean could be kept warm by Neptune's gravity and Triton's strange orbit. If this ocean really exists, it might even support alien life, making Triton an exciting target for future exploration. And let's not forget the plumes, these towering jets of icy material shooting into space. They not only show that Triton's geology is active but also suggest that there might be a reservoir of volatile compounds underneath the surface, ready to burst out. Despite its freezing temperatures, Triton is a world full of fascinating mysteries. That's not all, there's also the ammonia mystery. The ammonia mystery. Deep under Triton's icy crust, there's a secret reservoir of ammonia. While ammonia is a common ingredient in cleaning products on Earth, it plays a crucial role in Triton's unique subsurface ocean. On Triton, ammonia acts as an antifreeze, slowing the freezing process of water. This helps maintain a liquid environment beneath the icy surface, which might create conditions suitable for life, though these conditions would be vastly different from anything we experience on Earth. Sunlight adds another layer of intrigue to Triton's icy surface. Even though the sun is far away, its faint rays manage to penetrate Triton's thin atmosphere. This interaction causes a delicate process where nitrogen, the main component of Triton's atmosphere, becomes compressed underneath the icy shell. Over time, this pressure builds up and is eventually released in spectacular plumes that shoot into the vacuum of space. This dramatic phenomenon is unique to Triton and adds to its mystique as one of the most fascinating moons in our solar system. Unraveling Triton's true nature is a captivating challenge for scientists. The possibility that Triton has hidden oceans beneath its icy surface sparks the imaginations of many. However, proving this theory is no easy task. Triton's remote location, combined with the technical difficulties of space exploration, makes it a tough target for detailed study. The thin nitrogen atmosphere on Triton, shaped by the distant sun's heat, adds another layer of mystery. This fragile gas layer hints at complex interactions between Triton's surface and the sun. The way Triton's atmosphere responds to solar heating is still not fully understood, making it an exciting subject for ongoing research. Triton's origins tell a fascinating story of cosmic migration and gravitational choreography. This moon is notable not only for its size but also for its unusual backward orbit, which contrasts with the forward motion typical of most moons in our solar system. This peculiar orbit suggests that Triton may have once been a wanderer from the Kuiper Belt, a distant region of our solar system beyond Neptune. The Kuiper Belt is a treasure trove of celestial wonders. It's home to dwarf planets like Pluto and enigmatic objects known as trans-Neptunian objects. These icy bodies, ranging from a few kilometers to hundreds of kilometers in diameter, hold valuable clues about the early formation and evolution of our solar system. Studying these objects helps scientists piece together the history of our cosmic neighborhood and understand how it has changed over time. The Kuiper Belt is a truly amazing part of our solar system, and one of its most intriguing features is how it interacts with Neptune. Imagine two dance partners who move in perfect sync. That's what's happening here. Neptune's gravity affects the objects in the Kuiper Belt, causing them to orbit in a synchronized pattern. For instance, Pluto, which is one of the most famous Kuiper Belt objects, takes 2 trips around the Sun for every 3 trips Neptune makes. This kind of synchronized movement is a sign of a finely tuned cosmic ballet that has been in place for billions of years. The Kuiper Belt also serves as a fascinating time capsule from the early days of our solar system. It's filled with icy bodies made up of substances like methane, ammonia, and water ice. These icy remnants are like frozen snapshots of the solar system's infancy. They preserve a record of the conditions that existed when the solar system was just starting to form, giving scientists valuable clues about our cosmic origins. Neptune's cosmic journey. There's a lot of excitement among scientists about Neptune's past. One of the big ideas is that Neptune, along with its distant siblings Uranus, Jupiter, and Saturn, might have undergone significant migrations during the early years of the solar system. Picture these planets moving around a lot, much like pieces on a giant cosmic chessboard. This migration could have been triggered by gravitational interactions with other planets or even passing stars. If Neptune hadn't moved, it might not have been able to keep so many objects in the Kuiper Belt in place. The gravitational pull from Neptune helped hold many of these icy bodies in their orbits, preventing them from being flung out of the solar system. Without this protective influence, the entire layout of our cosmic neighborhood could have been very different. Neptune continues to be one of the most mysterious planets in our solar system. Despite its calm appearance from afar, it hides a world of secrets beneath its surface. Scientists are particularly curious about what's going on inside Neptune. They want to uncover details about its inner layers and understand how ice giants like Neptune form. This knowledge is crucial because it could help us learn more about the origins and evolution of these distant worlds. The more we know about Neptune, the better we can understand not just this planet but also other ice giants and their role in the universe. What's next? Looking forward, future missions to Neptune are likely to provide even more insights into this enigmatic planet. These scientific expeditions hold the promise of unraveling the complex chemistry and dynamics of ice giants. By studying Neptune up close, we can learn more about its icy composition and how it fits into the grand scheme of planetary systems. These missions will help us understand how planets like Neptune form and evolve, not just within our solar system but in other star systems as well. Each new discovery brings us closer to solving the cosmic mysteries that have intrigued us for generations, expanding the boundaries of human knowledge and fueling our curiosity about the universe. So, what do you think about this? Let us know in the comments section. Don't forget to like, share, and subscribe. And while you're still here, click the video on your screen to see more interesting content like this one.